This is the third video for CAM project number 1. This is the nameplate that we're going to be machining. But before we actually get to the operations, what I want to do is go into our tool library. So if we go down to the drop down and select tool library, a lot of different stuff will pop up. And what you're seeing for my tool library is probably going to be different from yours. I have done a bunch of operations, so I have a bunch of tools that I've created. But I want to show you how to go about creating the tools that we need. So if we look over here on the left, there are a bunch of sample type of tools, and there's a whole bunch of stuff. Here's actually tool holders, profile tools, all kinds of stuff. If I go to sample tools, inch, most of what we're going to be doing is inch, but there's times where we could have some metric stuff. I can see there's a lot of different tools here, a lot of round over, end mills, some looks like a countersink or a center drill, a lot of different stuff. And you may find something that exactly fits what you're trying to create, and you might not. But I'm going to show you how to create one, because let's assume that you can't find exactly what you need. I'm going to choose something that's in the right category of what I need. So for our project, we're going to use 2 end mills. So I'm going to find this end mill. There's a 3/4 end mill here. Oh, that's a bull nose. Let me see if I can just find a standard end mill. Ball end mill. Here's a flat end mill. So we're going to use this to create what we want. So I'm going to select this. Oh, go back. Where'd it go? There it is. Okay, right click and copy the tool. And then go back to your library and paste the tool. And now you have that tool in your library. But we're not using a 3/8 end mill. We're using a 1/8 inch end mill and a 1/4 inch end mill. So what I want you to do is duplicate this. And now with our duplicate, we can edit it. First of all, name it exactly what you need so there's no ambiguity later. 1/8 inch flat end mill. We'll do a 1/4 inch next. We're going to navigate this tab and change everything that we need to. For cutter, we could change it here, but we're going to leave it flat end mill. So really, you can pick any type of cutter and change it. I don't know, I just find it easier. That's a habit I have, is trying to select something close first. Pretty much all of our mills are going to be clockwise. Our number of flutes, we can just count that. So what you want to do is either have the specs of the end mill that you're programming, or have the end mill in front of you so you can take a micrometer or caliper and actually measure these things. Or in the case of flutes, aka teeth, you just count it. We're going to be using a lot of 2 flute end mills on wood. We could use a 1, you never know. Material is going to generally be HSS or carbide. Most of the beginner stuff we're going to do is high-speed steel, because it's much cheaper if you break it. And now this is where you would need to do a little measuring. So if it's a straight diameter, it's going to be 0.125, but sometimes we can use a larger shank and do what's known as a step down. It provides a little bit more strength. Our shaft diameter is actually going to be the same, 0.125. Overall length, that's actually 2 inches. Length beneath the holder is 0.875. Our shoulder is 0.75, and our flute length is 0.625. Now, if there's any errors, like you say that the shoulder is longer than the total length, then it's going to tell you there's an error and you need to fix that. On the right side over here, you get a little graphic of essentially the data you're putting in, or what your end mill looks like. We don't need to put anything for shaft or holder at this point. This is a little bit more advanced, but do know that it's there. And here's where you enter your speeds and feeds. Now, you can change this later, but this is the default that's going to go into all your programs. So the closer you get this, the less you have to change later. Now, our spindle speed for this, from what I calculated, was right around 15,000 RPM. And instead of putting in all these feed rates manually, what I'm going to do is just put in my feed per tooth. We're using a 0.003 feed per tooth. And as you can see, it changes my cutting feed rate. And for plunging, which is essentially drilling, there's a feed per revolution that you can do too. And usually this is a shade less than our horizontal feed rate. So for kind of a basic setup, this is going to work just fine, and I'm good with this. Do go to Post Processor and make sure that you give it the right number. If we're using a tool changer, you need to assign this to the right place in your tool holder, or the machine's going to grab the wrong tool and you're going to have a big problem. So for our setup, our 1/8 inch was actually tool number 2. And turret number 2 in our changer. I have some options here as well, but we're not going to go into that too much. Click accept, it brings you back here. You can double check that it changed it, and then you can close it. Now when you go to open up or to create an operation, that information, you can select that tool and all that information will go with it. So do the same thing for the next tool. Go to your library. So for the 1/4 inch tool, do the same thing. You can either edit this 3/8 end mill, or you can duplicate it and edit it. But do this twice, and that'll help you kind of learn that information as well. And if you don't know what to put in here, remember this is the specific geometry of the cutting tool itself. There's no special answer to this. Look at the tool, measure the tool. A lot of tools will come with this information on the package, assuming it's not loose in a bin somewhere. So that is a great place to look for that information, and also a good reason to keep it. And remember, the cutting data, this is what we are actually calculating. So this is what you guys know how to calculate from our formula page. All right, so go ahead and get those loaded, and then we'll be ready in the next video to create the operations themselves.